Hi, my name's Jose Johnson, and this is my lab submission for Physics 2111 Lab 3, Mass of a Black Hole. In the first step of this lab, I was tasked to create an orbit around a black hole with a random trajectory that was based off my Georgia Tech email. After getting the trajectory, I used physics concepts to simulate my star orbiting around the black hole while it recorded data about it. This data will help us accomplish the first goal of this lab, finding the mass of the black hole. Afterwards, we will use our results from the first section in the second part, where we are asked to find the initial velocity that would help us escape a planet orbiting a black hole without crashing into the planet and without being sucked into the black hole. Some key concepts we will go over is Newton's second law, that relates to the momentum principle, perpendicular and parallel forces, and gravitational force interacting with orbital motion. Here's the formula for Newton's second law, and we can also see the formulas for the change of velocity, time, momentum, and position, which will all be used in this lab. Next, we have the perpendicular and parallel forces, which allow us to break down the net force into two separate components. The parallel component relates to the magnitude of the net force, while the perpendicular component relates to the direction of the net force. This decomposition of the net force is very useful when dealing with orbital motion. The main focus of this slide is the gravitational force. Since we are in space, the only active force we can measure is the gravitational force. This equation labels it as the net force since it is the only force present. If we take the magnitude of the net force and solve for either of the masses, then we get the equation in this form. This equation will be useful in part 1 of the lab. On the right of the screen, there is a diagram of orbital motion, which is what this lab is looking at, so we will discuss more about this later in the video. For part 1, our system is a black hole and the surroundings is the star orbiting it. In part 2 of the lab, the spaceship is our system and the planet and the black hole act as our surroundings. As explained previously, we find the mass of the black hole to be this number here, and the initial velocity I found is here. Some sources of error in part 1 is I could have used a longer time interval to get a better measure of the average mass of the black hole to be more accurate. In part 2, if I were given the initial velocity of the ship, then I would have a cleaner, more accurate model of how the ship escaped orbit. For the first part of the code, I inputted my mass for the star of 2.0 times 10 to the 30th power. The second part of the code is where all of the previous formulas come into play. Here we are given the initial and final velocity and momentum, which allows us to find the change in momentum over the change in time, and also building net force from the parallel and perpendicular components. The end of the code is about the arrows in the model. The second snippet of code gave us new information, such as the planet's speed and velocity. The ship's speed was found through trial and error. In the next portion of the code, I calculated the forces of the black hole onto the ship and the planet, the force of the planet onto the ship, and the force of the ship onto the planet, which gave me the net force on the planet and the net force on the ship. Finally, I used those net forces to update the planet's and ship's position and velocity. The first part of the lab asked us to find the mass by using the formulas discussed earlier. What does this mean? How is the net force parallel and perpendicular components different from the change of momentum's parallel and perpendicular components? The net force is directly proportional to the change of momentum over the change in time. This lab is built around this idea and showcases it. In this section, we were able to calculate the forces between the black hole, the planet, and the ship to get away from the black hole without crashing into the planet, as discussed in the code. What if we wanted to orbit the black hole to look at all of its beauty? The ship's new initial velocity would look something like -2 times 10 to the 6th power in the horizontal component, and in the y component would also have a similar speed to the planet that is already orbiting it. In this lab, we found the mass of the black hole and used that information to determine how to escape the gravitational pull and how to orbit the black hole in the spaceship.